So this is the joy of simulating forces. And I hope this works. Yeah, okay. So hi, I'm Lisa. I'm listed on GitHub, where you can find all the stuff that I usually do. Also, if I were a boat, I would be this boat because it's called Liz. So the story goes that back in school, we probably all had physics classes and math. And I was pretty average at that. I wasn't bad, but I wasn't also very good. I was just average. And it was only until recently when I got into like programming and like making games and like even more recently, like more of like creative coding, more creative coding, that I thought about, I should probably look at physics again because you can probably do cool stuff. But I was still like, yeah, I don't remember it being fun. But then I realized coding physics is a lot of fun. It's actually really cool. And I'm here today to show you and talk to you about how much fun you can have with physics. Especially with forces and simulating forces. This is where the title of the talk comes from. So I made a demo and I hope this works. I'm gonna do a, can you see this? Ah, perfect. Okay, so this is the joy of simulating forces. This is online, so you can play around with it by yourself. And with this, we're already looking at the first lesson of physics, which this guy tells us about. This is Newton, and he has laws. And the first law is that an object either remains at rest or continues moving at a constant velocity unless acted upon by a force. So no forces, no movement. So yeah, let's act some forces on it. Let's activate the wind. And we can see that things start moving. In this case, the wind value here is like 0.1, which is like arbitrary value, means that it's like blowing like on the positive x-axis, and the negative would be like on the other side. And yeah, things move. But this is only like one of the laws that we have, because we already in this example had the other two laws that Newton talks about. Let's start with the third law, which is kind of like cool. So for every action, there is an equal and opposite reaction. What does that mean? If you look at the thing, we saw that the shapes, once they hit the wall, they kind of like bounce back a little. And this is because I made the wall like push back the shapes once they hit the wall. Except that this is not physically accurate, because when you do your own physics, you can also cheat your own physics. And you don't have to be physically accurate. So instead of like applying the forces in a real way, I just says like, oh, just like pointed to like the other direction, and like I don't consider math in like the pushback, the mass of the objects in the pushback. And you might be wondering, mass what? Which is where the second law comes in, because force equals mass times acceleration. So what mass? I gave the three objects different masses. And if I refresh this, maybe, yeah, and start acting the wind force again, you can see that the triangle accelerates faster than the others. This is because it has the less mass of the three. And the square has the highest mass, which is why it accelerates slower than the others. Isn't this magical? I love it. So this is really cool, and let's maybe like play around with it some more, and then we like can also have the wind blow from the other direction, like faster, and then they like bounce, and it's really cool. But it's only one force. Wouldn't it be cool if we have like a different force? Let's say friction. Friction is something that happens in the real world. So, for example, if this dog slides along this desk, it will experience friction, and this is the physical formula for friction. And this is like the thing where I'm like, formulas, you sometimes find them on Wikipedia, and it's like, I can't read this. And here's like a super magical trick where you can like cheat on the physics formulas. Like everything that you don't know, set it to 1. It works. So it's true. So in this case, we have mu, which is the friction coefficient. So like how much friction like would influence our force. Then n is the normal force, which is like 1, and then we have the velocity of our bodies or of our objects. So if I like blow the wind again in the other direction, maybe like with 2, and then I activate friction, and like that's really high, we should see that the things just like stop. because friction is now acting as a counter force to like the wind. And the wind is not strong enough anymore to like accelerate the things faster or like at all. The cool thing about like my fake physics here is that I can also have negative friction, which would then like with the wind accelerate the things even faster, which is not what would happen in the real world ever, but it's fun, and this is really cool. But we have more things. So let's deactivate wind and friction. Whoop, maybe, okay. And let's have gravity, if this works. Whoop. Which in my case, gravity is just like a force that pulls things down. But I can also have it like be negative. Ah, so good. And you know, like there's like other cool forces that you can like also play with, like drag force. So this is something that happens with liquids. So if you like drop a thing into a liquid, it behaves a certain way, and it like there are certain ways in which like forces play together. So this is like a very scary formula with like lots of things that I don't know. So half of rho, which is the density of liquid, but we set it to 1. Velocity, speed squared that we have. A is the frontal area of the objects that hit the water, but I don't want to calculate this, so this is 1. What I care about is the C, the coefficient of the drag force that we can then play around with, and then the velocity vector again. So in my thing, if I like activate liquid, so I have like some liquid, which has a drag, so let's make this like even like, well, a lot of drag. And if I then have my things fall down again, yeah, you see that like the objects with the highest mass sink faster than the others because of the drag. I did not ever try this with like actually introducing like the density of the liquid, and I have like no idea how this works. But if you want to like fork this and do your own, just like calculate something with rho in this. So, and yeah, so there's lots of like very cool physics formula, because physics is something that science people have thought about quite a lot, and then they put it on Wikipedia, or somebody puts it on Wikipedia, and then we can do something with this. And yeah, we can also like go into space if we want. So there's like a formula for gravitational attraction, which is kind of cool. So you have like 2 objects, and then they gravitate around each other. And then we have like this G constant, which is then something we can also manipulate. So I'm going to cheat a little because I made a separate page for that one. Yeah, so you can have, these things are like attracted, wow. I can drag if I can, oh no, here's a little different window. I can drag these things, and then they're like still being attracted, and you see how they form little orbits, and it's just like, ah, look, it's forces, so cool. Yeah, and I think this is already it. Enjoy forces and physics, and don't be afraid of formulas because they're cool. Thank you.